Okay, we're going to do the last section from chapter 7 today. So there is a 7-6 in the book, but we're not going to do that one. We're going to stop at 7-5. So this is 7-5. And we're going to put all the things together from the logs and the exponential things to solve some equations. So these are log and exponential equations. So we've learned how to switch back and forth between logs and exponents and how to condense logs together, and we're going to use both of those things to solve equations today. So we'll start out first with the log equation. So we'll do those first. We'll write down some steps and solve some. So our first step when we're solving a log equation, it's an equation that has a logarithm in it, is you want to get the log by itself. Sometimes there's a number in front or a number at the end. You might have to add, subtract, or divide to get the log to where it's just the log with the base and what you're taking the log of on one side by itself. Once you've done that, you're going to rewrite it as an exponent. So this is a good review of what we did in 7-3. Then once we've rewritten it as an exponent, then we just evaluate that and solve. So once we write it as an exponent, there's no log in there anymore, and then it's just pretty easy to do. So we'll do one, a pretty straightforward one, and then we'll do some that we have to actually get the log by itself. So here's our first example. And some of these examples I'm pulling from your assignment, so make sure you write them down. You'll have these kind of as a guide to do. And some I've modified a little bit, so they might not be the exact same ones. So the first one, let's say I had log base 9 of x is equal to 2. Okay, so I want to see if this is a log equation. There's a log in it. So my first step is I want to get the log by itself. So if you see there's nothing in the front, there's nothing added at the end, so it is by itself. Step 1 is done. Steps 2, rewrite it as an exponent. So we have to remember how do we write these as exponents. So if you recall, you go base, power, and that's what it equals. So we're going to rewrite this in this manner. So 9 to the second is equal to x. So we just look and see what is 9 squared. 9 times 9 is 81, so that's my evaluate part. That's 81. So 81 is x, and we're done. Okay, so x is 81. You can always double check it. 9 to the second power, yes, that is 81. So that's if you don't have a number in the front or you don't have any steps at the end. That's a straightforward log equation. We'll do one now where you've got to do something first before you can rewrite it as an exponent. All right, so here's our next example. Let's say that we've got log base 2 of n plus 6 is equal to 5. So if we look at this part, this is one that's from your homework assignment, so make sure you get this one down. The log's not by itself. We have this plus 6 that we need to get rid of. So the first thing that we're going to do is subtract the 6 from both sides. So we have log base 2 of n, and that's going to equal -1. So now the log is by itself. It's time to rewrite it as an exponent or a power. So 2 to the -1 is equal to n. Okay, and then you can just type in, if you don't remember negative exponents, you could type 2 to the -1 into the calculator, and it's going to give you 1/2. So n equals 1/2. And remember, a negative power just moves it to the bottom. If you're thinking, how would we do that if we didn't have a calculator? So the 2 would just go to the bottom. So n is equal to 1/2, and that's our answer. All right, one more of the exponential kind, and then I'll give you one to try on your own before we move on to, the log kind. We haven't done exponential ones yet. One more of the log kind before we move on to the exponential ones. Okay. Oopsie, that's a real thick one. Jeez Louise. You'd think after all this time I'd get better at this. And you'd think wrong. Okay. All right. So here's one that we're going to have to, oh, we actually have two log ones left. Sorry, I lied. We have to do something first before we can do the others. So here we go. Let's say I had negative 8 log base 9 of n is equal to negative 16. If you look at this, the log's not by itself. We have negative 8 in the front, so it's negative 8 times log. So to get rid of a multiply, right, to get rid of something that's multiplied, we know that we're going to have to divide. So we're going to divide both sides by negative 8. Okay, and the negative 8 goes away. So log base 9 of n is equal to 2. Ooh, we already did this one at the beginning. Then we look and we say, okay, now I can write it as a power. My base is 9 to the second equals n. And 9 to the second, we've already said, is 81. So 81 is your answer. Okay, I'll circle all those. All right, so I'm going to have you try one right now. What I'm going to do, instead of me typing it in, because these are hard to type into the program, I'm just going to write on your own and then write the problem down, and then it'll pop, a question thing will pop up, so you'll be able to type what you think your answer is into the box, okay? So this is for you to try on your own. On your own. Let's say that I had 3 log base 4 of x is equal to, let's go with 6. Okay, so this is for you. This is our first one to draw on your own. This is for you to try on your own. Remember, you've got to get rid of your 3 first and then write it as a power. So the question will pop up like right now, and then you'll be able to answer. Okay. All right. Hopefully you got that one right. I'll put, I guess I should, well, I've already done it because I'll go back in time and do this. I'll have multiple choice things, so it should let you know if you got it correct or not. We have some that we have to combine logs together before we get started on the actual rewriting part. So if I see a problem like this, log base 8 of x plus log base 8 of 2 equals 1. In the case where you see multiple logs in a problem, we have to just have one of them because we can't rewrite it if there's more than one. So we're going to have to combine these two together, and you have to think back from the last lesson and what a plus sign means with logs. So if you have 2 logs separated with a plus sign, remember that means to multiply the things that are here on the inside. So I'm going to rewrite this as a single log, and then I can switch it to an exponent. This is going to be log base 8, and x times 2 is the same thing as 2x. I'm not going to put the x in the front because that's going to look weird. Okay, so plus in the log world turns into a times, and remember that a minus would be a divide. So if it was a minus, you would have the x over the 2 or whatever. All right, now we're ready to write this as a power. So 8 to the first is equal to 2x, and we just evaluate that and solve. So we know what 8 to the first is. 8 to the first is 8. And x isn't by itself yet. We haven't seen one of these yet where you've got to actually do one more step at the end, but you all know how to do it. This is a one-step problem here. We'll divide both sides by 2, and x is equal to 4. Okay. All right, so if you've got 2 logs, you're going to have to combine them either with a multiply or a divide, and then we will solve. So those are our log equations. Now we'll do the exponential ones. Your exponential equations, it's pretty similar to the log ones. Your first step is when you want to get the power by itself. Or the exponent. Oh, 2 comes after 1, not 3. Then we rewrite it as a log. And solve. So when you're solving these, there's a good chance you're going to have to put them in the calculator using your change of base that you did at the end of your lesson last time in 7.4, where you had to put the log over log in the calculator. So I'll remind you how to do that real quick. So we'll just do actually, I think I have 3 examples of this kind, and then you'll be done. I'm sorry, this video is a little bit longer, but this takes more steps than what we've done recently. So our first example, let's say that I have 4 to the m is equal to 37. So before this, you've had no way of knowing how to figure out what that power is unless it was like a perfect square or a perfect cube. But 37, there's no way to do 4 to a whole number is equal to 37. So if we can rewrite this as a logarithm, then we can use that to solve it. Okay. So the power and the base, it's by itself. There's nothing in front. There's nothing added at the end. So that's good. Step 1, check. Step 2, we want to rewrite this as a log. So remember, we go log base 4 of 37 is equal to m. I can double check. 4 to the m is 37. Good, I have it the right way. And then now I just have to put this in the calculator. And so remember to put it in the calculator. Log 37 divided by log 4. Let me type that in real quick. Log 37. Make sure you close the parentheses. I think that's messing some people up. Divided by log 4, and I got 2.605 or 047. So that's close enough. And that's your answer. So you'll rewrite it as a log, then you can put that in the calculator. Okay. All right, here's our, actually, well, I'll do one more and then I can have you try one on your own. So if we check this one out, let's say I had something like 18 to the a minus 8 is equal to 23. So for this particular problem, the base and the power are not by itself. We've got this minus 8 that we need to get rid of first. So we know how to do that. We'll just add 8 to both sides. So 18 to the a is equal to 31. And then now it's set up perfectly for us to rewrite as a log. So log, there's our base, 18 of 31 is equal to a. Sorry, and then we type this into the calculator like before. Log 31 over log 18. That's 1.188. So 1.188. All right. Okay, so here's one I'm going to have you try on your own real quick. And then I think I have one more to do. So let's say that you had 5 to the x plus 3 is equal to 27. Okay, so 5 to the x plus 3 is equal to 27. So give that a go. Remember, you have to get rid of the 3 first and then rewrite it as a log and put it in your calculator to evaluate. Okay, so I want you just to tell me what x equals. And you'll answer it in your in your whatever when the question pops up. Okay. All right. And one last problem. Sometimes you have a step to do after you've rewritten it as a log and evaluated it. So these aren't too bad. And it's pretty intuitive what you do once you've done your last step. Let's say a to the r minus 5.8 is equal to 41. Okay, so at this point you may think I want to try to get rid of that 5.8, but it's actually in the power. So we can't do anything with it right now. You can't divide it, you can't add it because you can't get it out of the power yet. So you have to rewrite it as a log first, and then we can get rid of that 5.8. So the only time you can get rid of it first is if it's like the same size, like font-wise, as your base. Then we could subtract it. If it was at the end, we could divide it if we needed to. But if it's in the power, you can't do it until you've already written it as a log. So let's write this one as a log. So log base 8 of 41 is equal to r minus 5.8. So we first have to evaluate log 41 divided by log 8. And I got 1.786 equals r minus 5.8. And now you know what to do to get r by itself. We are going to add 5.8 to both sides. Okay. So plus 5.8, and you end up with 7.586. Is that right? No, equals r. Okay. All right. So if you have questions about this, let me know. But really, if it's an exponent, you write it as a log. If it's a log, you write it as an exponent. And we just combine a little bit from what we did in the last 2 or 3 lessons. So thank you for watching and have a great day.